Okay guys, so it's time to deploy the smart contract to the blockchain. Finally, we are going to mint the NFT ERC721 Smart Contract with all the information that we got populated. Everything is ready to go. We got the NFTs on IPFS. We got the metadata in IPFS. We got the metadata CID added onto the base URI in the smart contract. So once the user mints a token out of the collection, or an NFT out of the collection, the metadata can point to the image file of that NFT. So that is already done. We're ready to go. One thing that I would like to say is everyone that is showing me, thank you so much for those messages that I'm receiving. I'm getting a lot of DM messages. Thank you so much for that. And yes, also I've been getting requests to work on DeFi. Yes, I am going to build another set of video tutorials so you can deploy your own DeFi and use a liquidity pool from another DeFi platform, or you can learn how to do your own liquidity pool. I will be working with those smart contracts for you guys so you can learn about it, okay? You got it. Okay, so let's go ahead and work on our smart contract. First thing we wanna do, we got the smart contract ready to go. I just need to literally copy and paste onto Remix and execute a mint function. And we will mint the smart contract. You can see that live on our video. One last thing that we want to do before we go and mint the smart contract, let's make sure that the metadata is properly tied to the IPFS path. How do we do that? Let's go ahead and work with that. Okay, let me move this on the side. Awesome. So first thing we got to do here, we have to grab the CID. And remember, previous video, we discussed IPFS and how do we, connect the dots, NFTs onto IPFS, metadata to IPFS, and then we use the identifier for the metadata folder in IPFS. So once the contract mints the token, it can find the metadata file. How do we know that we have the proper identifier? Let's copy this and let me open a new browser window. And what we want to do is we want to go to ipfs.io, IPFS, let's paste, and now let's type one.json. JSON is the format for the metadata file. Let's make sure that we can access that, that metadata file. And boom, we got our metadata file, and we can see that we are opening the metadata file, and we can see the information that we populated. This is the image file, the image path for that NFT, so NFT number 1. Let's go ahead and copy now this, right? And we want to do the same test for the image file. So once we validate that we can open the picture, we know we're 100% good on the IPFS portion of our NFT smart contract, okay? So let me go ahead, same thing, HTTPS, IPFS.io, and then IPFS, and finally, let's copy and paste a full path, and let's see if we can open the picture. Okay, so the picture file, it's showing correctly. So we know that the path on the metadata file is correct. Now what we're gonna do, we are going to grab the smart contract and we are going to mint it. Like we know everything is properly configured. So for that, we need to head to remix.ethereum.org. It's basically Remix, it's an online Solidity compiler that allows us to interact with the blockchain. Not only Ethereum, but we can use any Ethereum-based blockchain, Polygon, Binance Smart Chain, Avi, Phantom. There's many out there. There's not just Ethereum. We can use that for many other blockchains. Okay, so let's go ahead and head to Remix. First thing we're gonna do, obviously, we have to open Remix. So we go to remix.ethereum.org. And this is how Remix looks like, okay? So Remix basically will give you a default workspace. A workspace is basically an area where you set your files, scripts, etc. So your .sol, which is the Solidity format, will be imported into the workspace, and then we can interact with it, okay? One thing that we have to be very careful is that by default it's going to have contract files like base contract or sample contracts that you can play with them, but in our case we just need to delete that, okay? So what we're gonna do, we're just going to go ahead into the contracts and we're gonna delete this one, we're gonna delete this one, and let's go to scripts, and we are going to delete the Web3 and the ethers. We don't need any of that. We just need to work with the smart contract. Okay, delete. Now what we want to do, we want to create a new file, and we're going to name this the NFT Smart Contract. Okay. So now we got a new, fresh editor screen. We just need to copy the smart contract, paste it here. Okay. So let's go ahead and do that. I'm just going to selection, select all, copy. And we're going to hit Ethereum, remix, paste. There we go. Awesome. So now we have the contract, the smart contract that we previously built, and this is all the information. We just need to make sure that everything is set, and we got the proper base URI pointing to our metadata hosted in IPFS. That is correct. Okay, we're good. Good so far. Now, what we need to do, we need to go under the compiler. So if you click on the left side, you're going to see, and let me expand this a little bit more so you can guys see this better. Okay. So we click on our Solidity compiler and it will open this navigation menu on the left, right? What we need to make sure, right now, the Solidity code, it's set to be compiled in 080. So what we're gonna do, we just change that to be 080, and you can change this version, so you can use a even newer compiler, but either way, you have to make sure that it matches, okay? And we obviously know that we're going to interact with Solidity. We just mentioned the Ethereum Virtual Machine version, or EVM version. It's the default. We'll leave that as it is. And we only need to click compile, and it's going to check if we have any errors. If we don't have any errors, we should be good. So let's go ahead. And nothing. It's perfectly compiled. It means that there's no syntax errors at all. So we're good to continue. Okay, awesome. Now, let's go on to deploy. And this is where fun things will happen. First, before we even compile the smart contract, we need gas fee. We need to pay gas fees. And that will be done on the Ethereum network or any other blockchain that we interact with. Let me explain real quick what a gas fee is. So the gas fee is basically you pay to process or make a call on the blockchain. What does that mean? It means that every time that we make a call or we make an execution to a smart contract on the blockchain, there's a process on the blockchain that will be mined. And that's where we are relying on miners to process that transaction. So they have to validate that the call is legit, that we're not, trying to spoof or fake or make any false calls. We need to verify and validate the integrity of the smart contract call. So we need to validate the integrity of the smart contract call. So for that, we need to pay gas fees. The more transactions or traffic on the blockchain, the more the gas fees will cost. And this has been a polemic. This has been a big deal in the Ethereum. There's always a drawback on the Ethereum blockchain because of high gas fees, and it's because the load of people, or in this case users, interacting with smart contracts. That will raise the gas fees even higher. That's why other blockchains are way more efficient, because they are not relying on proof of work. They're mostly relying on proof of stake. Proof of work, it's a consensus validation mechanism that relies on machines, or in this case, it could be ASICs, it could be graphical GPUs, or it could be CPUs, to process that transaction. So they basically look at the block and they start grabbing blocks and then connecting or making sure that that block puzzle matches, so then the transaction is successful. And we can see once we mint the smart contract, you're going to see that on Etherscan. So Etherscan is a blockchain explorer for Ethereum. It's basically it's a website that you can go and see live the transaction as it's been processed and it's been validated. So we're gonna see that. You're gonna see that once we mint the smart contract. I'm just gonna go to Etherscan and look how the transaction is going. Okay. So with that said, because we need gas fee, we need to pay gas fees. We got to get some Ethereum. We're doing this on a testnet. What is a testnet? Testnet is basically the equivalent of the mainnet. So we got testnet and we got mainnet. Mainnet is the actual production blockchain. Anything that you call in the mainnet is the live network. It's where we actually do crypto transactions, we buy stuff with crypto, etc. The blockchain validates that transaction, okay? A testnet, it allows us to mimic or emulate the real blockchain. And why is that very helpful? It's very helpful because we are not going to pay real money to interact with the testnet. We can validate and make sure that the blockchain is properly processing those transactions, or our code is properly configured or working as expected without paying gas fees. And no one wants to, waste money if the code is not, properly or optimized. So we use the testnet to validate everything, okay? But for the testnet, I still need to pay gas fees. How do I get free Ethereum, or in this case, free fake Ethereum? There's something called a testnet faucet. Okay, so a faucet allows me to receive free fake Ethereum to perform blockchain calls using the testnet. In this case, we are using the Ropsten test network. In the Ropsten test network, and you can see my MetaMask wallet, I can select the mainnet, which is the production Ethereum network, or I can go ahead and use the Ropsten test network. There's others, but I'm just going to use this one. The Ropsten test network, I still need to receive Ethereum because I am going to make my smart contract call or mint function on the smart contract using the test network. I still need to use I still need to have Ethereum, but this will be fake. How do I get free Ethereum deposited onto my account? I'll copy the address, then I'll go to a faucet. You just go to Google, type Ropsten faucet. Any of those sites that are offering you free Ethereum, you just grab and paste your address, and then you click send me some Ethereum. Okay? Once we get that, wait a couple of minutes, up to an hour, you should be able to get an Ethereum. In this case, I think they are giving 0.03 Ethereum. There's another faucet that actually gives more, which I already called. And this one will give you 1. So that's even better. Okay? So that should be good for our video. Okay. Now that we have the test tokens, we went to the faucet, we requested some tokens, we got the tokens issued. Now we can go back to the Remix compiler, and I can perform the call. I can actually mint the smart contract. So let me zoom out a little bit here. Okay. Now that I have this, the smart contract ready to go, has been compiled, no errors, everything is looking good to go. I need to change my environment. Right now, it's using the JavaScript virtual machine, which is basically not the testnet blockchain. It's just an emulator, and I cannot actually interact with my wallet. This is just an emulator just to see if the contract can call or can be called on the blockchain just fine. We want to make sure that we change this to be injected Web3. We change this. The moment I do that, it's going to tell me, hey, this is my main account, but this one, it's going to tell me, hey, how much, which account I need to use, right? Because it's now the moment I do an injected Web3 call, basically the browser is going to look for a wallet, crypto wallet, and it's going to try to interact with that one. In this case, I'm going to use my test wallet, right? So we're going to use this one. We'll press next. And we'll connect. And now I am effectively connected to the Ropsten blockchain or the testnet. Okay. Next, what do we have to do? We have to mint the smart contract. That's all. All we have to do. How can we do this? Very important. The moment I compile the smart contract, it's going to build a set of files or a set of contracts based on all the information that I provided on the smart contract. All my interfaces, you can see ERC, those are all my interfaces. The only thing that we have to make sure that we have selected on Remix from a contract perspective before we deploy is our actual name of the smart contract. This other contracts, you don't need to compile those. Only the one that is labeled the test smart contract, okay? This will be net to def. which matches net to dev. This is the one we want to mint. Okay, so let's go ahead, grab this. The moment I click deploy, it's gonna open my wallet. It's gonna ask for those for that Ethereum gas fee. We click and the smart contract is minted. So let's go ahead and deploy. Now it's opening the wallet, right? So let's take a look at the wallet. Now it's basically telling us, hey, I'm going to charge you 0.009 ETH for that gas fee. And then minting the smart contract plus the gas fee, it's going to cost us 0.0935, which is nothing. And trust me, this is not the price in the real Ethereum mainnet. It's not. Like, I minted a smart contract like 2 weeks ago. It cost me like $1,500, so $1,500. So it's not cheap. However, this is just a testnet. Okay, so let's go ahead and confirm, and we're gonna mint the smart contract. Confirmed, and let's see how it's looking. We should be waiting for that confirmation. Let's see. Let's wait for that, and I should see also a confirmation from, there you go. We got MetaMask telling us the contract has been minted on the blockchain, on the testnet in this case, and we got a confirmation. Now it's telling us a view on Etherscan. Etherscan is our block explorer for Ethereum. It's a website that is very, very, very useful. It's very, very valuable to understand. I'm going to do a different video just walking over Etherscan and how. I'm going to do a very interesting one. I am going to do a video that I'm going to show all of you guys how to pull data from Etherscan as an API call. So then you can populate your website with data, related to sales of NFTs, transaction volume, how many NFTs do we have left on the supply and all that. So you can display that on your website. All right, awesome. So let's go to Etherscan. Let's take a look at this. How can we see? Obviously, this is the Robston test transaction. This is not the real production network. It's telling us right away. We got the confirmation. It was a fake mint. It was a fake miner confirmation. Now it's telling us the wallet that executed the smart contract and what's called this. How do we call this wallet? This will be the owner wallet of the smart contract. So the owner, it's basically this wallet right here. And we effectively have a contract address. This is the contract that we need to update. This is a contract value that we need to update in React.js, in our JavaScript code. So once the user hits the mint button, it talks to this particular contract, and then it's able to buy an NFT from this smart contract, okay? What do we have? Now we have a token. Remember the token that we coded on the smart contract? Let's go back to the smart contract, and we see the token symbol, and we see the token name. If we go back to the contract, this is what we have right here, okay? If we click the token, you can see that there's no supply. Why there's no supply? Because everything is being held on the smart contract. The moment someone mints a token, it starts increasing. In this case, if let's say everyone buys every single NFT out of the supply, this should reflect 1,000, right? So that means all those tokens were minted. But right now, no one has minted anything. Okay, what else is very useful? Now that we have Remix, I'm going to show you a cool thing to also do some testing and some review. Inside Remix, you can actually expand the contract. You're going to see this under deploy contracts, and you are going to see every single function that we have in the smart contract. We got obviously the mint function, in which the user is going to call that using React.js. We got an approve function, which is basically done internally. It's not done by the end user. It's not a public function, okay? What can we also say? Withdraw. Withdraw is a function that allows the owner of the wallet to withdraw all the crypto that was collected from every single sale. Once a user buys an NFT from this particular smart contract, the Ethereum that he paid or she paid for the token, for the NFT, will not land in your wallet. It's going to land on the smart contract. And you, as the owner of the smart contract, can click here and withdraw that crypto, so then it gets deposited onto your wallet. So you have to be very careful, because your wallet is the owner of the contract. If you lose your wallet, you're not going to be able to withdraw the money from the smart contract. So make sure that keep that in mind. We have, we got some show show commands, or in this case, some read commands. You can click the base URI. You can see the base extension. Let me see the base extension. We know it's going to be .json. So any metadata, let's say token 1, so it's going to have 1.json, 2.json, 3.json. Max supply. Let's see how much token supply do we have on the contract. 1,000. Perfect. So that's the amount that we specified on the smart contract. 1,000. It's what we have. There's no more than that. Okay. Max mint amount. This is the amount of tokens that someone can mint on a single transaction. Total of 5. So now we know that this has been called correct. Okay. Because we haven't mint any single NFT, I am not going to be able to call this. I need to already have a minted NFT. Right? So once we mint the NFT, we should be able to go back here and do this test command and all that. I'm going to show you more of read command, but I need to mint NFTs. But before we mint an NFT, we got to build that React.js server. Okay? So on our next video, we are going to connect the smart contract to our React.js website, and we are going to buy an NFT from our own website. You should feel proud. Like you build an NFT mint website. You can build smart contracts, sell NFT collections. Look at you. Awesome. Okay. Sweet. On our next video, once we do that, then we can see some interactions. We're going to buy an NFT, and then we're going to go to a marketplace. Let's go to OpenSea, and we should be able to see the NFT listed in OpenSea. Alrighty, so if you like this video, please give it a thumbs up. Please subscribe, so that helps me a lot to continue doing this content for you guys. And let's go on to the next one. Take care.